Welcome to today's webinar. I'm excited to share with you our AI software factory demo, and I'm going to share it to you today not as a coding tool. There's plenty of those out there, but as an executive level architectural pattern for overseeing and optimizing software delivery. This is about orchestrating how software moves through an organization so that we can systematically increase throughput while keeping quality high. And we've had a tremendous response to the offering of this demo, and we have an enormous number of people who are watching. And so I'm going to try to get through this as quickly as I can while showing everything, and then reserving some time for Q&A so we can use the Q&A window and the chat window in the streaming software in order to do that. So let's get right into it because we have a lot to cover. And if you want to share the link with some of your colleagues so they can get in on it, that's great. Go ahead and do that. Okay, so you're probably wondering, well, what the heck is an AI software factory? Um, in our world, software delivery is a constraint, and demand for changes and new software is increasing. Our team sizes are mostly fixed. They don't change that often. Sometimes you form a new team, maybe add a new person, reorg, split a team. That does happen, but you're not just dynamically increasing capacity. Most of the time, you set the size of a team, and then you run with it, and then you try to optimize throughput. And software delivery throughput, it typically lags the business needs. Your business partners are asking, when is it going to be done? When is it going to be done? And things typically don't, oh, surprise, we're finished early. Things typically take longer than expected. And again, the business partners or product management is asking, when is it going to be done? And even as new as AI for coding is, the promise of AI is eluding a lot of people. It's not clear, well, how do I exactly put this in place? We've kind of already moved past the hype curve of, oh, AI is just going to magically do everything. Well, everybody kind of understands, no, that's not the case. But we, at the same time, we kind of see the promise of it, and we have to put it in place systematically. And so, um, and so we're going to look at that. We're going to look at this different way of thinking. And the notion of a software factory is, kind of a decades old concept. And there were, conferences many years ago talking about the concept of a software factory. And you could say a factory is putting together an overall workflow where raw materials move in on one side of this figurative factory, and then finished goods move out the other side. And so we've kind of adopted that with our Kanban pattern, where we have a series of statuses represented by columns. We move digital cards left and right, left to right. That's kind of our assembly line, is the sequence of the statuses from left to right. It's the series of the stations of work that we have put together for our figurative assembly line, where things start at the left and they move to the right. And so, what is an AI software factory? It is using the artificial intelligence technology to automate that which can be automated. And I think what we'll see is that for certain types of work, we can darn near automate 100% of it. And for other types of work, maybe we can only automate a small portion of it. I'm not here to tell you that AI is going to do every bit of software delivery. It's not. However, it's new tools in our tool belt that make a little bit more automatable. Okay. And so we want to pull out those tools and use them where they're going to fit. So AI really doesn't do anything automatically. We know that it has to be operated. It's a machine. It runs on a computer. It's just another way to automate things. Um, Now, we all also want our teams to move faster. And I'm going to get into the demo in just a second here, but I need to tee it up. Um, we want our teams to go faster, but just by wanting the teams to go faster, it doesn't just happen. We can't put pressure on it. We can't say, oh, we need to move faster. And I mean, you might say, oh, we need to work late or we need to work weekends. Well, that diminishing returns because then we burn out the team and then, you're going to take a sick weekend instead of a planned weekend. And also, quality problems consume the capacity. When defects slip out of our process into production, into the customer, they come right back, more expensive to resolve than if we had just done the right work to prevent it from getting out in the first place. Also, production incidents, uh, they're disruptive to the business, and they also consume our team's capacity because when a production incident is happening that's disruptive to customers or our company's abilities to operate and make money, whether it be revenue or cost management, then immediately that becomes the highest priority, and it steals our team's capacity to do feature work because guess what? They're working on the production incident. And also, even within the process, rework steals time from working on new features. If we think that something is done and we move it on to, maybe final manual testing with product management, and then product management comes back and says, well, no, it's missing this and it's missing this, or this wasn't ready to test, or okay, this new thing is good and working, but now it looks like this other feature is broken. It's great that it didn't slip out to production where it's impacting our customers, but it's still rework within the process. And and so we all have to analyze that and optimize everything together. And AI is not going to automatically do that. And AI is not going to give us perfect work consistently all the time. Um, Quality and stability are not nice to haves. They are prerequisites. If defects or incidents consume our team, then there's really no capacity left for throughput. No matter how much automation we add, and an unengineered AI adoption can make delivering defects into production happen much more quickly, and we don't want that. So enter the AI software factory concept. We It is an orchestration pattern, and I'm going to show you the demo number one just here in a second. But it's an orchestration pattern for the entirety of software delivery and automating the parts that can be automated with AI. We already accept orchestration patterns in software delivery. We have for a long time. The AI software factory is kind of the next level up. It coordinates the entire life cycle from idea to getting that into production. And we have orchestration in continuous integration, continuous delivery with automated deployments. Even the concept of a sprint is orchestrating, 1 week or 2 weeks, a period of time. And so we have these smaller orchestrations where there's a workflow and we measure it. This is the next level up. Um, and so this is a critical concept. The AI software factory is about building a system where automation does the repetitive work and engineers focus on engineering. Okay. There is certain work that there's no obvious solution, and it actually needs some engineering. And the whole process of engineering is converting ambiguity into a concrete design. Or going into a system where there's a problem. Hey, I need to do this. It's not exactly clear. And look at the options, look at the tools we have available to us. We might need to run some experiments and proofs of concept, or coming up with some options that are workable, choosing one of them, and then putting it into place. Okay, there's plenty of work that requires engineering. Th- Then there is work that doesn't require any engineering. It merely requires some programming. And that's what I want us all to focus on right now with the AI tools that are available to us right now as just an initial implementation of what I'm going to show you is think about your organization and think about the easy stuff. Think about the stuff that doesn't require any kind of engineering. It's already a slam dunk. You already know exactly how it needs to be done, but somebody has to do it. It merely requires some programming. And software engineering is different from programming. Programming is one of the tasks that fits within the umbrella of software engineering. It is how we take an engineering decision and make it reality in the software. But programming does not equal software engineering. Software engineering is greater than programming. So, for our AI software factor, I want you to think conceptually, what are the types of work or what are the pieces of work in each stage that are pretty darn clear cut? It doesn't, low ambiguity, but it still has to be done. Still has to be done by some person on our team. But what if it didn't? What if it could be automated? Okay. When we talk about when we talk about AI in a software delivery um, process, we are not throwing away the multiple decades of innovation in the past, and we are not adopting some brand new process. We are adding in additional pieces of automation to a complete software delivery process. What you're seeing on the screen uh, is a structure, a flow, and architecture for a complete AI DevOps environment where you have everything from what needs to happen on a engineer's workstation through work tracking and builds and testing and building and packaging and deploying and telemetry. And this is the top 1/3 of this poster. It's large format. It's if you've been attending our trainings for a while, you might even have our long tenured DevOps architecture poster. So we have revised and up-leveled this, and now this is our new AI DevOps architecture poster. It's meant to be printed on 2 foot by 3 foot paper. That's architecture D. If you would like a high resolution copy of this, you can just request that in the chat, and my assistant Kaylee here will make sure that we get that to you in the high resolution PDF form. And this is just the top 1/3 of the poster that we have here. I'm not going to go into every detail, but I want to highlight a few things. All right. You'll notice that we call out version control, we call out continuous integration, we call out a series of environments that we deploy all the way to production. Going back to 2006, there was a book that was called Continuous Integration. That was 20 years ago. There might be someone who's listening right now who's never read the book or even flipped through the book that defined the pattern of continuous integration. If you haven't, I highly recommend that you do it. Paul Duvall is the author of it. I actually interviewed him a few months back on my AI DevOps podcast, which you can find that on YouTube or anywhere, Apple Podcasts, Google Play, anywhere you get your podcasts, the AI DevOps podcast. And there are three core parts of the original continuous integration pattern that live to this day that are so important. It's the commit stage, which happens on my computer, the private build. It happens on my computer, so I know if I'm ready to share what I've changed with my team on a feature branch. And then the next stage is the integration build, where I mix my code with the code from other team members and we make sure that the software is still stable and that we didn't break anything. And then the third stage is the first deployment to the first environment. And that verifies that we can still package the build, we can still deploy it, and it will still start up and still do what it used to do. Okay, those are the three core patterns. I'm not going to go deep into that, but it's really important that you have a complete DevOps process, and I'll talk a little bit more about that. Okay, so let's get into the demo number one. And what I want to show you, I'm bringing over, is a GitHub projects board, and it's a little small. Um, so we have an empty board. We have one item that's in development, and then we have a whole bunch of things that are done. So um, we have to have a Kanban board that is representative of all the stages in our process. And I don't care what you call these statuses. I really don't. What matters is that you have a board, and for your organization, it has all of the things that are necessary to go from an idea of a change to the software all the way over to the software being done, released into production, and stable, being used by customers. And so that means that after you've changed some code, you need some series of testing to make sure that it's good. And most people need some stage where we're just making sure that the build is functionally good. Okay. And then there's another stage where product management or business analysts are looking at it from a customer usability perspective, and they want to make sure that it's what the customer needs, and some type of user experience testing. And most teams also need some type of status or station of work that represents that it's been validated and this is ready to go into production. And maybe we're validating telemetry and that it's good to go. It's supportable if we're using any feature flags, and then we push it into production and it's done. Most teams, they need at least those different stages because they're different things and they're done by different people. Leading up to development where we change code, most teams need a few stages of design decisions. From the conceptual definition is where, from a business analysis perspective, we are figuring out what the heck we want to do. That's the concept, the business concept. After that, we have to make some design decisions of how do we expect people to use this? What's the user experience going to be when this is all done? We have to decide that. And then after that, most teams need to make some type of technical decisions for how we're actually going to do it. Do we need any new architectural patterns? Do we need new NuGet packages? After that, we need to figure out what the definition of done is. What are the test scenarios? We have one happy path, a few exception paths. How many different scenarios do we need to test to make sure that this thing is done? And then armed with those design decisions, then we move in and we change the code. If we omit or overlook any of these design decisions or points of analysis, well, then we're going into the code blind. And if we're missing any of these, yes, it makes it harder for me to program the right thing. And it probably leaves some problems for later on where product management is looking at this and then says, wait a minute, we're missing something. We're missing this. We're missing that. Well, because we didn't clearly identify it, maybe in user experience design up here. But if it makes it ambiguous or hard for me to program the right code and do it completely, then there's no hope for an AI tool to be able to do it either. Okay, so this is the foundation. Now, I want to run this demo because what we have here is uh, I have another screen. I'm going to click a button to create some items on the board. All right. So we are creating a backlog. We have a virtual product manager in the background. You'll see that there are items that are popping up, and we're going against an application that I'm not even gonna show you. Actually, I will show it to you because it it kind of brings it home. So let me go to, this is one of our environments here. And this is the First Church of Springfield in The Simpsons. This is a work order management system, and we don't have even um, password authentication. We just easy demo application, and I can create a new work order. I can look at my work orders, and I can see that I've assigned one to groundskeeper Willie for lawn maintenance, and I can look at that. We have some translating and speaking and we have some AI assistants here. We have an AI agent. This is a demo application. We've demoed a lot of things. That's not the point. It's an application. And one of the ways that we can we have a health check endpoint using the .NET Health Checks library, and we have a healthy application there. So that is the application, and we have some items here, and we're gonna let's say, I don't know, force capitalize all the names in the dropdown. I'm gonna come over here, and I'm actually going to not make this dim. I'm gonna make it real, and I'm gonna say it's there we go, and we're gonna auto merge a pull request because it's pretty darn easy. And so the concept is here. It's pretty darn easy, and let me make sure those labels took, because the labels are AI Software Factory keys off of those. And let's see. Yep, it's already moving. And if we move these over here, and if I label all of the issues as AI Factory, if I come over here, it should be, yep, AI Factory, then they'll start getting picked up. Okay, and they'll start getting worked. Let me shrink the font so that we can see all of the columns. All right. Now, I showed you that we have Control F5. Okay. I showed you that we have our health check endpoint and we have a healthy application. Okay. While our demo is running here, just refresh, make sure these are getting picked up. And demo and these things. Okay, there we go. Things are moving. Perfect. Let me click off of this. Okay, so I've started the AI Software Factory, and these things are being worked. And if something happens in production, oh, actually, before I do that, I'm going to take one of these things, and I'm gonna take it off of demo, and let's see, auto hide navigate, and I'm actually going to assign it to Copilot, and I'm going to make this a manual. So there's always a mix of work going on. So stopping the login button from blinking, this was something that had already been done. We have the branch here. It's been assigned to Copilot. And this is one that needed some engineering, just figuratively. And so our AI Software Factory is not going to do any analysis or work any of these columns as it's going forward. But while this is happening, if something in production happens and our application goes unhealthy, um, then that's a common scenario. Okay. So if we are unhealthy, if I come back here and I've actually borked the environment, and if I hit now, it's unhealthy. Okay. Why is it unhealthy? And we can manually just say detailed. And it looks like we have some good ones, several health checks. Ooh, memory is corrupted, restart the process. This happens all the time where there's something, and from time to time, you know what? We don't need a code change, but if we restarted the process, we would get past this production incident right now and we'd all be fine. And so what we've seen is in the release queue, we see this new production incident, and then we've already had some analysis where we've kind of identified that we believe that we can resolve this incident without a code change if we just restart the process and then re-verify. So our AI Software Factory has been monitoring the environments and has put this in place. And because it's something that's in our knowledge base, something that's happened before, maybe every 3 months or so, something happens, but we can resolve it just by restarting a process, then we can do that. It doesn't require any code change. So we put it on our board after development, after we create a build, because we don't need a new build for that. Now, if it's something where it's not clear cut how to resolve it, maybe it's not in our knowledge base, well, then maybe we need to create that card earlier on in technical design so that we can identify how we need to do that. And um, so we have a process, and I know this is speeding up time, things constantly moving across the board. But you probably ask, well, what just happened? did we actually make the environment healthy again? Well, let's go back to the health check. Actually, I can just refresh the detail. That's fine too. And process memory is healthy. And if we can go here and see, it's healthy again. Okay. And because it's healthy again, it works just fine and we can use the application. So what actually happened to just automatically resolve that production incident? If I go down and open this production incident, we can see that in the background, our AI automation journaled a few comments on what it did. And wait a minute, cursor. So, we can hook up GitHub Copilot. That's an AI agent. It can do some things. Cursor can do some things. Claude can do some things. OpenCode, JetBrains Junior. There's all Gemini. There's all kinds of AI tools out there, and that's fantastic as long as we have some method of orchestration to make this thing happen. So I have our cursor, um, our cursor agents. If I just refresh this list, and we can see, oh, production incident response 1 minute ago. And of course, you can see lots and lots of other cursor sessions that have happened. You can see work item test design, the login drop-down name, capitalization. You can see some that have plus 65, minus 17. That's where 65 new lines of code happened. 17 lines of code were removed. This was 285 lines of code were added, 67 lines of code were removed. These are the ones for development where we actually changed code. The ones that don't have a plus and a minus is because no lines of code were changed. Maybe it was just the work item user experience. So I'll come back to that. But production incidents response, you can see that it was resolved and it worked for 1 minute and 3 seconds. So before I could finish talking, it was already resolved and it had a remediation. And then at the bottom, we applied the ready to move label. And that way our AI software factory can see, oh, this item is ready to move. It was fine. Okay. And so the prompt, we have a canned prompt for production issues. Won't go into that. But we have called the Cursor API to automatically create a session to work on the issue, the production incident, and I'm going to open it up again, production incident, and it was of type production incident because we have feature work, we have bugs that we catch before, we have bugs that we explicitly catch, and then there's production incidents. And so for each type of work item that is in your process, you often want to do different things. And whether you're going to dispatch it to Cursor or Copilot or Claude or whatever tool that you happen to use, the type is going to dictate what kind of prompt that you've configured to give to Cursor. And this is very efficient because let's see, will it tell me? Yeah, it worked for 1 minute and 3 seconds, and and it didn't even write any code because it didn't need to write some code. It just needed to do something. And with all of these AI tools that have cloud environments, we can configure the environment with the right environment variables, the right personal access token, the right access to anything we need to so that it can do exactly what we want it to do, but it doesn't have access to do anything we don't want it to do. So let me pull back to work item UX design 1769, and you can see that we worked it and we appended user experience done. Let me show you that. Work item UX design, this is 1769. Now I need to find 1769 in here. Let's see if I can filter. 1769. There we go. Force capitalized, filtered it. And we can see that we started with a concept. And so if I dispatch this column, when it moves through this column, if I dispatch it to Cursor or any of the AI tools with a prompt, well, I don't need to write any code at that point. I just need to, if it's something very easy, then the AI tool can inspect the existing code base and documentations and design diagrams and anything we have and come up with some guidance for user experience design. Again, we're talking about the easy stuff. We're talking about the stuff that doesn't require engineering. It's not ambiguous. It's pretty darn clear cut what we need to do. and we just need to have somebody do it. And then in technical design, that was a separate prompt, a separate session, and this section was added. Again, we're harvesting existing patterns from the code base because language models are really good at just matching patterns. And then with our test design, that was another prompt, another session, and we've added what types of tests need to be added. Now, we kind of all have learned that if we do a separation of plan and code with these AI tools, that the AI tools tend to do a better job. And so if we gave an AI tool this information, well, there's going to be probably mixed results. But what we've seen over time is if we give the AI tool all of this information, then the AI tool can do a pretty good job. Now, we didn't even look at all of this information. That's right, because this change right here, it's a pretty darn easy change. Anybody on our team could do it. There's no ambiguity. And so all of this in user experience design was derived from the code base and the documentation itself. It was derived. Technical design, it was derived from the code base. And then test design, it was derived from the code base. See acceptance tests end to end. So, um, so that's a good example of having the entire board and then uh, having every column have an individual prompt, dispatch it to an AI tool, and then move it across. Let me get rid of this filter because our system has still been running, still been working on things, moving things across. Okay, let me come back to the slides here. All right, that's our first demo. And we're gonna have plenty of time for questions, so please send them in as you're thinking about them. Okay, so you're probably asking, okay, so what exactly is the AI software factory and how does it fit in? Because what I'm seeing is I'm seeing a GitHub Kanban board. Well, that's true. I mean, GitHub, Azure boards, Jira, there's plenty of, very widely used work tracking boards, and all of them provide integration with webhooks and APIs where if I create something on the board or move something, it will call my system. It'll call a webhook on my system. My system is the AI software factory. Okay. Um, just like your automated DevOps environment is a series of bits of automation that kick in based on certain triggers, the AI software factory is one level up. It is a system of triggers and actions that listen for certain things that happen. In other words, moving an item across the board and trigger things like dispatching a prompt to Cursor or Copilot or Claude or whatever AI tool you want to plug into that particular column when we believe that a work item or a portion of a work item can be done by an AI tool. And you don't have to have the entire bit of work for that column done by the AI tool. You can have, just maybe work item enrichment. You could just have the gathering of documentation and attaching files to the work item or pulling more information together. Whatever portion of the work is automatable, then we want to do that. Okay. Now, everything that follows that I'm going to show you hinges on three core capabilities of the AI software factory. First is clarity. Second is the ability to change. And the third is the ability to forecast. Okay. The first one, clarity, is your visibility. Most teams only see fragments of the process. Product management might focus on the front. Development teams, sit in the middle, not started, in progress, done. And then maybe production operations and customer support focus on the live site. The AI software factory approach treats software delivery as a single system holistically with all of these stations of work so that we have clarity into what feeds into what and where the bottlenecks are. Each station of work has that named status with a certain type of work that has to be done in order to move it forward. And when we can't move forward because we missed something, well, the work moves backwards on the Kanban board. The Kanban board, it in of itself is a great pattern, but the work and it is our mechanism for tracking work. It's our work tracking board. It has to be comprehensive. It has to have all of these. Um, you know, executives would not run finance without a they have financial statements. They have weekly cash flow forecasts. They have budgets. They have budget to actuals. They wouldn't run a business without those financial statements. Running software delivery without a similar level of visibility, it's the same mistake. But because no tool does this automatically, we have to put it in place intentionally. Yes, no tool does this automatically. GitHub Projects doesn't give you this. Azure Boards doesn't give you this. Jira doesn't give you this. There's a lot of reports that are kind of built into these systems, but those reports are they give you some intel, but none of it gives you the whole orchestration in a way that allows you the ability to tune and change and improve while forecasting what the change is going to do. Because if we have a hypothesis that introducing AI into a certain portion of our software delivery workflow is going to be advantageous, we have to be able to measure that and measure that granular enough so that we can prove that it was a good idea. And so I touched on forecasting. The third capability is the ability to forecast future releases and future projects. Um, we use the same manner of measuring actuals and tuning them, and then we can project that into the future, either assuming that we won't change, that we will continue on our current track record, or forecasting what would happen if we do change one of our variables or some of the manner in which we're moving ahead. All right. So this leads me into my second demo. All right. So let's go into that second demo. All right. So we worked this. I'm going to show you our scorecard, which is our measurement component of the AI software factory. All right. So while I've been running this work through our board, a combination of a couple of manual ones, a few production incidents. I have not run through any escape defects, so you'll see all those are zero. I just didn't run any through, but I did run through a couple of production incidents. So we have but this is based on minute. Let me go to hour because I ran a few, and this is UTC. I haven't converted it um, to local time. But we see I ran through a new production incident, and we did that, and stability issues resolved was one. Okay, I'm going to clear this data, and I am going to, so I have, by the way, just so you can see what I'm doing, I have a simulator dashboard, and I am going to, I'm going to clear the data. Okay. And then I'm going to simulate a team that is running. Now I'm going to simulate, a decent sized team, 10 developers working 8 hours a day. We're going to simulate 60 days, and we're going to simulate that 30% of our work items, our features, end up getting released in production with some type of defect, and we're going to have 3 production issues per week. So I've got a lot of levers in here to simulate things, and even the number of minutes per column that we actually have to work, the amount of AI automation, all these are set to 0. Okay. So right now we have no AI automation. I kind of demonstrated for you that we can take the work of any particular column and we can dispatch it to an AI tool, a cloud AI tool. I'll show you the one with Cursor. Of course, GitHub Copilot, Claude, and many more to come. And then we have the percent rework for particular columns because sometimes we move it along and have to move it back. Okay, I am going to start measuring. Pull this away, and you can see that actually I'm going to do it per day until we have a sufficient amount. And you can see that it's calculating the amount of throughput, so a little more than one per day. I'm going to change the roll up to by week, and we can see, ignore the first and second columns. We're just spinning up the column. We have a product manager that's creating new work and doing conceptual definition. The progress is when something moves from one column to the other. So if I have 9 or 10 columns, then I'll have 10 times as much progress as I will new work. Throughput is when an item reaches done, and mean time to delivery is the number of weeks that it takes for an item once it's started to reach done. Okay, so we're simulating 60 days, and work in process is kind of stable. And actually, let me do 7. Okay. Good averages. So on average, we have 13 throughput, 13 per week, and mean time to delivery is a little less than half the week. So roughly, yeah, 2 days per item to deliver and work in process. So we're not quite keeping up. And defects escaped. We have some that are escaped. Of course, when a defect escapes, we prioritize that over new work. Same thing with production stability. And so we're measuring all these. By the way, let me take a pause. Even if you're not trying to introduce any AI automation, you have to have, at a minimum, this level of measurement of your existing project. Okay. You have to. Otherwise, you're running blind. You have no idea on average how long it actually takes you to deliver a feature. And you could say, oh, some features are larger, some features are smaller. Well, that's true. But when you track things over time, you have what's known as the law of large numbers that kicks in, and the averages start to become dependable, where you can say, you know what, we've been tracking for some number of weeks, and it seems to be that the mean time to delivery, it's kind of stable. It doesn't, if we average the last 7 weeks together, it's pretty stable. And so you can kind of rely on that. If you have 10 more items that come up, each of them is going to take, 2 business days to deliver. And now you can start forecasting. That beats any any individual person's stick the finger in the wind estimate on how long it's going to take. You actually use measurements to forecast into the future. So I'm going to take this particular team and we're going to do some work, and we are actually going to uh, increase our quality assets, improve our testing, and we're going to achieve some reduction from 30% of our items being released into production with a defect to only 10% of our items released. And we're also going to uh, work on production stability. We're going to get down to only a production incident every every 2 weeks. Now, when I say production incident, I'm meaning one that we notice, one that's actually a business disruption. I'm not talking about some alert that says, "Hey, we need to do something with storage." If it's not disruptive, it's not really a production incident. Okay, so let me just do that, and then let me come down here and our rework. When we improve quality, the amount of rework is also going to reduce. So I'm just going to cut these margins in half because we're gonna we're improving our quality. So we found some strategies where we improve the quality. Then I'm going to change to forecast mode, and we're going to start. And so remember that our throughput was 13 and mean time to delivery was 4. And we can run this simulation multiple times, but as we improve, we need to be able to see that our numbers are getting better. Okay. If we're gonna figure out how to do more activity with the same team capacity, then we're squeezing out quality problems, we're squeezing out stability problems, and we're automating that which can be automated using AI technology. We're taking things that a team member would have to do and we're figuring out a way to delegate to the computer. Okay. And so the AI tools are going to continue to get better and more plentiful. That's why I call the AI Software Factory an executive level orchestration pattern over the entire software delivery process because it gives us the surface area to analyze a particular type of work and realize that with the tools available to us, we can take some of that work or we can take a lot of that work and we can figure out how to get a computer to do that work. Whether it's just with regular old school scripting and automation or whether it's with an AI prompt. Okay, so we ran for another 60 days, grouping by week, roll up period is 7. And so now, as opposed to 13, 14 throughput per week, we are now averaging 20 work items delivered per week. And our mean time to delivery has gone down from 2 business days to 1.5 business days. Okay, down from zero point 0.4 to 0.34 weeks. And we can see that before the current period, we were running 3, 5, 2, an average of 3 defects escaping into production per week. And after, sorry, this is roll up. On average, if I do 20, we were 3.28, but of course the last 7 weeks is better. Um, 2, 2, 3, 4. Okay. And then production incidents, you can see one every other week versus multiple per week. And so the distractions don't happen. Now, okay, this is not even introducing AI. This is just tracking actuals and realizing how much capacity is being stolen by defects that escape out to our customers and by stability issues of production. Now we have the surface area to introduce AI. And so we come to our AI automation and we have 2 different categories. AI automation for simple work items and one for large complex work items. I'm not even going to mess with the large complex work items because that's not what we're demoing today. I'm going to only simulate simple stuff, easy stuff. And for the easy stuff, let's say that we're not automating conceptual definition because it's so easy to first place. But we are going to automate 75% of the rest of this. For development, for the easy stuff, it could be 100%, but just functional testing and I'm for UX testing, I'm only going to do 50% because with AI tooling, the integration with Playwright and the ability to take screenshots and validate visually is coming along big time. And probably a year from now, we'll be able to get 90%, but maybe not right now. And then the evaluating telemetry and are we ready for release? Let's just leave that. We're going to have humans involved here. Okay, so let's do that. And let's simulate for another 60 days. And so remember these numbers. We went up from 14 to 24 from the current period and went down from zero point 0.4 to 0.34. So let me run this simulation from the current period again. It's going to clear the previous forecast data. So we're back to our 14 and zero point 0.4, and we're going to run the simulation again. All right. And we have 3 of our weeks, and mean time to delivery has already dropped to zero point 0.2 from zero point 0.4. We're up in the 17s, 18s as we keep on going because our AI is doing some of the work. So our team, we still have the same size team, but now our team is able to focus on more of the work that does require deep creative analysis, actual engineering, and AI is taking the easy things. So it looks like we're okay. Now we're done. And so now our throughput got up to 20 per week, and mean time to delivery went down to under a day on average, down from 2 days. Okay. So that's a huge increase, absolutely enormous increase. Okay, so let's get back to bringing this home. So the AI Software Factory, we want to, first off, we need to model every stage of work. Second, we need to establish a software delivery scorecard. And then third, we need to monitor our throughput, our quality, our stability trends. And then we identify the bottlenecks and process gaps. We evaluate where we can plug in our AI tools. And we treat the AI automation as a hypothesis. We have to measure. And so to get started, take the simple paths, take the simple production incidents where there's already a knowledge base article or a run book where you kind of know how to do it. And if you had some automation that already restarted processes or bumped something off to the side, bring that into your process by using AI automation to create the work item on the board so you have visibility to how many times it's happening because maybe there is this latent bug that we need to fix in the software. All right. But start with the low-hanging fruit first. And in doing this, we design for future automation because this gives us the surface area to be able to have a continuous improvement loop and improve from there. Okay. Now, you have to have robust continuous integration, DevOps pipelines. You have to have comprehensive automated testing. You have to have uh, uh, observability capabilities, and you have to have, production health monitoring. But you've already got all those. Okay, those are, I'm just calling them out as prerequisites for the AI software factory pattern. All right. Now, this is an executive level pattern. All right. This sits atop every software system, every software team, and then the aggregation of all of the teams and all of the systems can roll up to an enterprise level scorecard for executive level reporting. All right. This gives executives real control over software delivery outcomes without the guesswork. And we can get started by plugging into existing software teams. You all have a work tracking process. We can get started by just plugging in and starting by monitoring and modeling your existing work tracking system that you're already using and giving you some insight for where might be the first place to insert some AI automation, but also at the same time, helping you optimize the software delivery flow. So, what's ClearMeasure's role is to help you through the adoption journey, and we would love to do a AI software factory implementation for you, get you those weekly scorecards so that you can start analyzing what's going on in your organization. You can start small, you can go big, and everywhere in between. Um, we are. I'm going to get to questions, but I want to do this invitation. If you use the QR code or the link that Kaylee is going to put in the chat, you can schedule a private AI AI implementation strategy session with us, and we'd love to help you get started implementing AI for your software delivery organization. All right, and let me go to the Q&A window and let's see what questions we have because I know that that was a lot of information and let me pull it up. Okay, you can start putting in your questions. Let me just make sure that I have the chat window. Where did it go? There we go. There we go. Okay. One of you asked, where can I get that high-res version of the AI DevOps poster? There is a link in the chat, and there we go. All right, here's another question from Marcus. What about AI governance policy and legal liability documents? I've heard from other companies this must be done first. So the AI software factory is an executive level orchestration pattern. Whatever is necessary and whatever is normal work, normal process, normal governance, normal policy, normal inspections, normal reviews, whatever is normal in your organization, you have to model it. And it's always I love the imagery of a factory in like a physical factory where raw materials come in one side and finished goods come out the other side because that helps us visualize what is the what is the sequence of our stations of work for everything that we need to get done in order to have some good finished products? Well, whatever legal review, whatever governance policy review, whatever inspection, whatever needs to be done, we have to model it. If it's important, it needs to be visible. And if a certain type of work requires some standards or requires some governance policy to put in place to oversee that, fantastic. Then it needs to be early in the process. So um, every organization is different from a brand new startup company to, established companies and highly regulated industries. Whatever is necessary work, you have to model it because whether you're using automation or doing it all 100% manual, that's important work for your organization. And so you need to know that it's happening and know how long it's taking to happen. So I, I only showed you rolled up numbers, but in the data, we have the ability to split those numbers by by status. And so then we can see what is the bottleneck and what is taking a long time, and maybe we need to improve the process for getting that work done, or maybe dedicate more people or figure out how to automate some of it. So, great question, because that's important. All right, another question. Um, we don't have that many statuses on our work tracking board. Do we need all of those statuses? Okay, I mentioned before. Uh, I don't care. And I'm going to actually change to this. I don't care um, what you actually uh, call these statuses. It doesn't matter what you call these statuses, but the concepts are what matter. Pretty much every team has something called development or in process. Now, Jira and GitHub and a lot of other systems, they start with a very small number of columns. They might just have, not started and then in progress and then done. That is woefully inadequate. That's not correct. You go into any actual factory and there is not just one big workstation at the middle of the room and you dump all the materials. There is a sequence, there is a flow. The software development life cycle, it is multiple decades old, and there is a flow of decision making on what we need to do, how does it need to behave, how are we actually going to make it happen, when do we know that we're going to be done? Okay, and now that we've made those decisions, now I can write the code. And after I've written the code, I need to check, well, does it work or is it totally broken? And then two, is it usable? Can a person actually use it? And then after that is it supportable? And then we can go to production. That's a minimum. Okay. So I don't care what you call these things, but you need to have your full workflow represented on your work tracking board. Again, I've just used GitHub here because it's easy for me to make it public and um, but all of them have, webhooks and APIs where you can hook in and do these things and you can model it. Jira, Azure Boards, GitHub, those are probably the most popular, but there's all kinds of work tracking systems. And in today's day and age, they pretty much all support the same things. All right. All right. Another question from Tony. For compliance, is there any tooling that you can recommend for MCP or AI servers that keep things secure? All right. So uh, there are keep things secure. Secure is not a binary. Secure depends on um, all kinds of things. But just like any other non-functional architectural characteristic of your software system, security is one of those things that you have to bake into the software itself. And your implementation of the AI software factory, just like your existing DevOps automation environment, that is part of your software suite. And so you're going to have to analyze that. Now, there is all kinds of tooling that is coming out in the market. Um, for I don't have one off the top of my head because I really haven't done a complete survey of these, but um, that might be a good topic for a future training. Um, and as I remind myself and all of you, it was only May of 2025 that AI coding started becoming prime time. Before then, it was haphazard, but it was May of 2025 where we really had a leap forward. And then it was October or November when Opus came out. And a lot of people have since had their Opus moment where they realize, wait a minute, I can actually define something and I can turn it on to Opus and I can go and have my lunch break. And when I come back, it's actually the way that I specified. I'm not like fixing all kinds of weird things. So the landscape is moving so quickly that this time next year we're gonna have so much more in our tool belt. And I think that's always going to be the case. But this orchestration pattern gives you all of the surface area necessary so that you can take whatever AI tools are here now or come out in the future, and you have a place to plug them in. All right. That's what's important because every one of these bits of work, you probably think about features differently than you think about escape defects. You think about those different than you think about production incidents. And so for each one, some or a lot is going to be automatable. But then for some other things, you want to have no automation and completely reserve it for manual processes. And that's fine, but we need to orchestrate the whole process. So sorry I didn't have a good answer for that, Tony. All right, as we close up here, thank you so much. And use the link. And I'd love to schedule some private AI strategy sessions with you, either with you individually or bring some colleagues and some of your fellow managers and software leaders, and we can help you put in place a plan for implementing AI in your software delivery organization. Thanks so much. Have a great day and God bless.